When even Nobel Prize-winning physicists question our understanding of the universe, it is clear that we have entered a new era of astronomy. Adam Rees is not the only one concerned. The James Webb Space Telescope is increasingly discovering cosmic structures that challenge traditional cosmology. How can galaxy formation, previously thought impossible, now be confirmed? These surprising discoveries raise questions about the future of our research and whether previous theories have reached their limits. Simple questions require complex answers. For example, the question of how fast the universe is expanding seems simple on the surface, but it is at the heart of a mystery that has puzzled experts for years. It is widely known that the universe has been expanding steadily since its birth about 13.8 billion years ago. This means that galaxies are moving away from each other at a rate proportional to their distance. In other words, if Galaxy A is twice as far away from Earth as Galaxy B, then Galaxy A is also moving away twice as fast. American researcher Edwin Hubble was the pioneer in discovering this correlation. To calculate the speed at which two galaxies are moving away from each other, you need a constant, the Hubble constant, that multiplies the distance between the galaxies. This is where things get tricky. There has been considerable disagreement among experts about the exact value of this constant. Previous measurements have yielded conflicting results, with values varying depending on the measurement method used. One way to measure the expansion of the universe is based on the cosmic microwave background radiation, which is a nearly isotropic fingerprint of the early universe and strong evidence for the Big Bang theory. Using this radiation to calculate the expansion rate gives a value of about 67 kilometers per second per megaparsec. For context, 1 megaparsec is 3.26 million light-years, and 1 light-year is about 9.4 trillion kilometers. In contrast, using Cepheid variables, a type of star that exhibits periodic fluctuations in brightness, to measure distances in the universe, the expansion rate increases to 73 kilometers per second per megaparsec. This suggests that the universe is expanding faster in our neighborhood within about 3 billion light-years than it is expanding overall. This discrepancy between the two values is known as the Hubble voltage, and so far no researcher has been able to explain this unexpected change. The James Webb Telescope has turned its attention to this mystery. Some scientists have previously suggested that the mystery surrounding the expansion rate could be due to measurement errors in the Hubble Space Telescope. Adam Rees was also interested in seeing if there were any errors in the Hubble data. Rees, a physicist at Johns Hopkins University and winner of the 2011 Nobel Prize in Physics, along with other researchers showed that the expansion of the universe is accelerating. Rees and his team used the James Webb Telescope to investigate the cause of this discrepancy in the Hubble expansion and look for possible measurement errors. To understand how the expansion of space is determined, the so-called cosmic distance ladder is used. Each step of this ladder builds on the previous one. That is, any error that may occur in one measurement can affect all subsequent steps. However, the above method is only reliable to a certain extent. The greater the distance, the more difficult it is to make accurate measurements. This is because the light from a star mixes with the light from other stars, making it difficult to see clearly. But the James Webb Space Telescope is 100 times more powerful than Hubble, allowing experts to see farther and in greater detail than ever before, and to delve into the deepest mysteries of the universe. A study published in Astrophysical Journal Letters provides a revealing picture. The James Webb Space Telescope scanned the entire region previously observed by Hubble and found no errors in its measurements. So the Hubble tension problem persists. Adam Rees offers a short but insightful explanation. Perhaps we have misinterpreted the nature of the universe. Now we have to figure out what we missed in previous observations and how to connect the origins of the universe to the present. This decision puts Einstein's theory of gravity to the test. But researchers working with Adam Rees are not the only ones trying to understand Hubble's entangled voltage. Scientists from the University of Bonn and the University of St. Andrews are also investigating the mystery and have proposed a new possible explanation. They propose that our planet exists in a bubble-shaped space with relatively little matter. The density of matter is highest near the bubble, and its gravity pulls the galaxy toward the bubble's edge. As a result, these galaxies are moving away from us faster than expected. This explanation is plausible, but it leads to another research dilemma. Why doesn't the standard model predict bubbles or structures that shouldn't exist? According to the Standard Model, matter should be evenly distributed throughout space. The Standard Model is based on Albert Einstein's theory of gravity, but it's possible that gravity doesn't work the way Einstein predicted. For this reason, scientists looked into a modified theory of gravity proposed in the 1980s by Israeli physicist Mordechai Milgram. But the so-called modified Newtonian dynamics, while accurately predicting the existence of these bubbles, has not yet achieved general acceptance. If gravity really does behave according to Milgram's ideas, then all discussion of the Hubble voltage can be left behind. In this new context, there would only be a constant for the expansion of the universe, along with the observed discrepancies due to the uneven distribution of matter. Time will tell how far this approach will be accepted and validated, but examining the past of the universe can give us an idea of how much remains to be understood about the future. Sometimes a single piece of information can overwhelm even the most experienced astronomer. For example, the record redshift of galaxy GN-Z11 suggests that this gravitationally bound cluster of stars already existed 400 million years after the Big Bang. Meanwhile, the oldest known galaxies raise an intriguing question. How could they have been so bright and massive so soon after the birth of the universe? Thanks to the Webb telescope's NIRCam, near-infrared camera, we have discovered that it took these structures about 100 million years to reach their current size. This young galaxy challenges almost all theoretical models and simulations of the early universe. This galaxy joins 6 others that the James Webb Telescope added to its star map in early 2023, and they too were found to be much more massive than expected. These galaxies existed when the universe was only 500 to 700 million years old, but they are similar to today's Milky Way. The researchers have dubbed them cosmic destroyers. As expected, in contrast to the young galaxies, the researchers observed impressive objects with star masses greater than 10 billion solar masses. One of them may even have a mass of over 100 billion solar masses. The question now is how this was possible. If even one of these massive early galaxies is confirmed, it would push the boundaries of our current understanding of cosmology. To explain their existence, the density of matter in the early universe would have to be 5 times greater than our models suggest. Or perhaps these galaxies evolved in ways we don't yet understand. These findings raise an urgent need to rewrite our understanding of the early universe and perhaps the Big Bang theory itself. If our models are wrong and the density or formation of early galaxies is completely different, we may need to rethink the very timescales and structure of cosmic evolution. This could have implications not only for our understanding of galaxies and their expansion, but also for our views on dark matter, dark energy, and the cosmic web that binds galaxies together. The James Webb Telescope results are more than just data. They open the door to a whole new understanding of the universe. Each new discovery challenges models that scientists have relied on for decades, forcing us to rethink our basic assumptions. So not only has the telescope shown us distant galaxies, it has also shown us that the universe may be much more dynamic and complex than we ever imagined. One thing is certain. The James Webb Telescope has brought us to the threshold of a new cosmological paradigm where the unexpected becomes the norm. We are only at the beginning of this journey. As the telescope continues to explore the far reaches of the universe, who knows what other secrets it will reveal? Let me know what you think in the comments. If you like this video, don't forget to hit the like button and subscribe for more interesting content. Thanks for watching, and I'll see you in the next video.